Counting outcomes is a fundamental concept in probability theory. It is the process of determining the number of possible outcomes of an event. Counting outcomes is essential in calculating probabilities of events, as we saw in the last video that the probability of an event is the ratio of the number of favorable outcomes to the total number of outcomes in the sample space. When we have a small sample space and we are trying to find the number of outcomes for only one event, it is easy to count the outcomes. In our case, counting the outcomes for event A is easy because we have a small sample space with only 5 pebbles for event A and 4 pebbles for event B. But what if we are asked to find outcome of drawing a red and blue pebble? How do we count the outcomes? Since we have a small sample space, we can flatten the pebbles of both events and count the outcome by iterating each red pebble with all blue pebbles like this and adding up every possible combination of red and blue pebbles. But what if our sample space looks like this, or even this? You can imagine that counting outcomes for both event A and event B manually would be a tedious task. This is where we will need to use combinatorics to help us count the outcomes of events. Combinatorics is a branch of mathematics that deals with counting. It provides us with rules and techniques to count the number of possible outcomes of events in a sample space. One such rule of combinatorics is the multiplication rule, which can be used to count the number of outcomes of multiple events. Multiplication rule states that the number of outcomes of multiple events is the product of the number of outcomes of each event. Let's apply the multiplication rule with our sample space example. Since we have 5 pebbles for event A and 4 pebbles for event B, the number of outcomes of drawing a red and blue pebble using multiplication rule be 20, which is what we saw when we counted the outcomes manually. Let's take another example to understand multiplication rule better. Suppose that you are buying ice cream. You have the choice of selecting a cone or a cup. For each cone or cup, you have the choice of selecting a flavor. The available flavors are vanilla, chocolate, and strawberry. We can visualize the outcomes of selecting a cone or a cup and a flavor as a decision tree. The sum of the leaf nodes of the decision tree will give us the total number of outcomes of selecting a cone or a cup and a flavor. In this case, the number of outcomes of selecting a cone or a cup and a flavor is 6. As you might have guessed, using the multiplication rule, we could have calculated the number of outcomes as well. Also, note that selecting a flavor first and then selecting a cone or a cup will give us the same number of outcomes as can be seen with this decision tree. We basically multiply the other way around to get the same number of outcomes. This concludes our today's discussion on counting. In the next video, we will learn about binomial coefficient and see how it can be used to calculate complex possible outcomes. Thanks for watching.